Hey, eighth grade. So our learning target today is I can represent real world situations with inequalities and absolute value like we did yesterday. But we're going to talk about something called deviation or things that are possible or a range of values. Today it's a little bit different. There's actually a formula. So it's an absolute value question where you have your variable or your unknown here. How much variation is possible is part of kind of what we do here. Your perfect score, we'll talk about that means in a minute, would go here. So we take the range that's there, we subtract our perfect score, we have our absolute value jail bars, and it has to be less than or equal to what we're allowable deviation or allowable change. So what we would allow plus or minus. So here's our first example. Your body temperature is a great example of where we allow some deviation. It doesn't have to always be perfect to the stated 98.6 degrees Fahrenheit. So our formula would say this: the goal or the perfect score is 98.6 for your body temperature. However, your body temperature can have some deviation. We just don't allow it to deviate more than 2 degrees either way. So you can be less than 2 degrees from the perfect score or more than. So there's deviation. So our formula would state this: we have our unknown variable. If we consider a perfect score of 98.6 degrees Fahrenheit, we will allow our standard deviation to be no more than 2 degrees change. So that's 2-degree standard deviation. So this is what the setup would look like. We have our variable or unknown of what it was possible. We take away our perfect score, and that has to be less than or equal a 2-degree change either end. So your correct answer of the setup here would be choice A. Now we're not asked to solve anything in this particular question, just set it up and kind of think through. Okay, so that is the formula there. Now if I'm going too fast, go ahead and pause that video. Again, perfect score is 98.6 degrees in terms of your body temperature. Allowable deviation, we're going to allow you to deviate plus or minus 2 degrees on either end. We're going to try that formula again one more time before we start to solve. All right, question 2. A clothing designer is selecting models. This is not my favorite question, by the way, but it's a good example of the change that's allowed. To run the walk the runway for her fashion show, the designer prefers models that are no more than 3 inches away. So they're going to allow you to have a deviation of 3 inches in your height from being 5'10". Now 5'10" is known as the perfect height for the models that they're looking for. Again, I hate this question. But moving on. Since 5'10" is the same as 70 inches, which inequality could be used to determine? Now we're going to use 70 inches instead because it's a little bit easier to talk in 1 unit rather than feet and inches, 2 units. So we have this formula. It says we have our variation there. Our perfect dream would be to have exactly 70 inches, which never happens perfectly, or rarely happens perfectly. We will allow no more than a 3-inch height either way, so 3 inches less or 3 inches more. So we're going to say we want our deviation or our range to be less than or equal to 3 inches either side. This would be our equation setup. Again, we're not solving, we're just getting it set up, getting comfortable with absolute value deviation. So correct answer should be B. All right, guys, let's move on to one where we actually solve now. So we're going to have to set it up again like we did. We're going to have to solve it, and then we're going to have to graph it. So it's going to be really become kind of a 3-point problem here. So you're pretending to heat, or you're pretending, sorry. You are preheating an oven at 350. That's known as the perfect score. Perfect score. The thermometer reads 346. The measured temperature has an absolute deviation of at most 2 degrees. Write and solve an inequality to decide if the oven is preheated yet. Okay, so our formula says this. We have our range, our perfect dream temperature that we need to cook our, in my case, frozen pizza is 350 degrees. That's perfection. That's what I need it to be cooked at to cook the perfect frozen pizza. But we are going to allow a deviation of 2 degrees either direction. So 2 less, 2 more. So at most 2 degrees can we be off and still be able to be fairly satisfied with how our pizza turned out. So there's the formula or the setup. That's step 1 worth 1 point. Step 2 is to be able to solve that. Now, we've learned with absolute value equations that we rewrite the equation one time without the absolute value symbol, exactly how we see it without the symbol. So x minus 350 degrees is less than or equal to 2. We write it one time just like that. And we've learned that we write it again one more time. But we flip the sign and we make it negative. So there's our two possible answers for deviation here. What are the possible ranges of degrees that are acceptable so we can still tolerate our frozen pizza? So we're going to solve this equation on the left. It's a hand method here. Solving for the variable x, we're going to add 350, copy, paste. So working left to right here, our x variable is all alone. That was our goal. That zeroes out. And on the right-hand side, we have 2-degree variation plus the 350-degree perfect score is 352. We will accept 352 degrees. We will be able to tolerate the pizza at that temperature if we cook it at that temperature. Another example, the other end then. What else will we accept? Well, we stop, chop, chop there. We're going to solve getting the variable alone. We add 350 degrees, copy, paste, working left to right. We will also accept negative 2 plus 350 is 348 degrees. So our scenario says this. Perfect pizza is 350 degrees. Not all ovens are functioning at perfect. So we have to have kind of an acceptable range where the pizza still takes okay. 348 is our lowest temperature that we will accept. 352 is our greatest temperature that we will accept. So if we go ahead and take a look at that, we will accept anything that's 352 exactly or less, kind of thinking shading left there, decreasing in value. So I'm going to set it up as you can see on the screen in blue. We will also accept 348 exactly or more. We will not accept anything less than 348, however. So growing. So we are going to accept the range of temperatures for our oven, for our perfect pizza, between 348 and 352. Notice the closed circle at 348, as well as the closed circle at 352. We will accept both of those as tolerable pizza temperatures. So there is our graph. So it's a 3-point problem, one for the setup, one for the equation work, and one for the graph. All right, guys, moving on to our last problem here. Last problem, same scenario. We have this deviation, or the thing that we would accept. A golf ball manufacturer puts 390 golf balls in each box. That's their goal. That's the perfect amount. Now, when you have lots of people involved, you have machines involved, mistakes do happen. You've maybe noticed that even in packages that you've purchased of other items. The box can be off by 6 golf balls for them to say that it's acceptable. Write, solve, and graph an absolute value inequality that displays the acceptable amount of golf balls that can be in each box. Okay, so we're going to start by the equation that says we have some variation happening here that's acceptable. We are going to subtract off our perfect score of 390 golf balls as our goal. That's the perfect. However, as a company, we are going to allow a 6-point change, plus or minus. So our change we'll allow is less than or equal to by 6 golf balls. Okay, so that's 1 point being able to set up using the absolute deviation formula that I've given you in the top of the note sheet. I'm just working through that formula. Now I have an absolute value inequality here, so we've learned that we rewrite it one time, ignoring the absolute value bars, exactly how we see it. And then we rewrite it again without the absolute value bars. However, we flip the sign and we make it negative. So that's going to be our second equation. We're going to be solving 2 equations here. All right, great, gang, here we go. We're going to solve. We're going to solve hand method. We're going to add 360, copy, paste. Working now, left to right. If I haven't used it, drag it down. And we have 6 plus 390 is 396. So we would accept up to 396 golf balls in a box and say that that's okay. There's going to be human error. There's going to be machine error. There's just going to be things that happen, but we don't want more than 396 in a box to make it acceptable. Otherwise, we're going to start losing money at that point. Then we're going to add 390, copy, paste, working left to right. So if I haven't used it, drag it down. The least amount that we'll accept is 384. Now, of course, that's not going to make the customer super happy, but from a company standpoint, we're going to say, well, that's okay. We can handle 384 or more. All right, so the possible range of values then on the lowest end is 384 is the least amount that we will accept. On the upper end, the greatest amount that we will accept is 396. So there's our range. We will accept exactly 384 or more. We will exactly accept 396 or less. Now they're growing to each other. So we're going to close that circle at 384. We're going to close that circle at 396, and we are going to shade in between. So there's the perfect amount. Of course, our goal was exactly 390. That's our perfect score. But from a company standpoint, we will accept that range on either end. Okay, so that's known as standard deviation. That's where we have that variation that happens. We talked about the model example. We talked about the temperature on a stove example. We talked about golf balls, and we talked about that your body temperature is not always perfect. As long as we're within 2 degrees, we say it's okay. So our summary today is just a quick little summary of our formula. The formula that we use when we have a deviation is we take the variation, we subtract off the perfect score, and then we say that that deviation or that change cannot be more than 2 degrees. So the deviation has to be less than or equal to whatever amount is given. So this is the formula. We're going to work through the formula today. All of these, if you go to solve, should have 2 answers because all absolute value formulas do have 2 answers. Your homework for tonight is to get through this page that we're currently working on, page 36, 37, due tomorrow. Page 36, 37, due tomorrow. Have a fabulous night.